Hi, everyone. Well, that was some music.
Oh, beautiful, right?
Are we all asleep or awake? I'm not really sure. All right. Welcome to Building for Massive Scale and Security with HashiCorp Cloud Platform. I'm Rosemary Wong, Chief Developer Advocate at HashiCorp and author of Infrastructure as Code, Patterns, and Practices. Here with me on stage is Cole.
I'm Cole Morrison. I'm also a developer advocate. Prior to this, spent 10 years on the front lines doing DevOps, software engineering across a lot of different categories.
Now, you're here today thinking about what's massive scale. Refer to last year, we also did massive scale. So this is focused a little bit more, specifically on massive scale, but what you should be thinking about from a lifecycle management perspective, right? We're here at AWS. We're curious about how we manage our infrastructure and security. And that, by extension, means the lifecycle of our infrastructure and security resources, right? And the reality is today, all of our infrastructure and security lifecycle management is effectively the practice of changing infrastructure and security resources. Change sounds simple, but it turns out to be the most complicated exercise that you can do in large-scale systems. So if you're thinking about, well, what does it even mean for me in the first place for doing this at scale, it means that you need some kind of automation and tooling to support that, right, Cole?
Right, and obviously this is a HashiCorp talk, so if you're curious as to what exactly we are doing, like our entire product suite, everything from Terraform for managing your infrastructure as code on AWS to Vault for your secrets management, everything Rosemary just talked about, that's what we help with.
Yeah. But I'm not going to scare you too much right now.
Oh, really?
It will get scarier. It'll get scarier because we're not just talking about Terraform and Vault today, so warning. But today we're going to go through a few of these simple actions, and we're going to relate them to some patterns and principles for lifecycle management. So lifecycle management at its core is 4 actions, which is a real oversimplification. You're looking at me being like, really, is it? But actually, right, you're creating resources, you're reading information about them, using them to inform how you update them, and ultimately you'll deprecate or delete them, right? These 4 actions are very simple on the atomic level or on a local change level, but they're much harder from a global level.
And do these look familiar? If you've done any type of development at all, software development, if you've worked on an API, if you've worked on a Terraform provider, you've probably been thinking this idea of create, read, update, and delete.
Yeah.
So it's very useful for this as well.
Yeah, that's actually how I based this talk on it. I was writing a Terraform provider, and I was like, actually, if we do these actions on a local level or an atomic level, we can actually scale it up to a much larger level. But it gets more complicated than that, right? We said create, read, update, delete, but it turns out there are some building blocks you have to have in place, some patterns and principles that you have to be thinking of before you get to scale, right? And all of them map to simple actions. So read, meaning monitoring and observability, creation, meaning modularization, access control, update for standardization, remediation, delete for immutability, ephemerality, right? These are broken up into 2 pillars, one for infrastructure, one for security. And then you get to scale, which I could call the roof, because I don't know how to better describe it. But it's the roof, and the roof has systems of record, self-service as code. Right? In your systems, what you'll find is if you don't have those foundational pillars for infrastructure lifecycle management and security lifecycle management, you don't put these foundational elements in place correlating to actions like read, create, update, delete. It's very hard to do everything related to scale at the top.
And in the talk, the title is Massive Scale. So this is also something we're building towards. So when we're talking about scale, we're not just talking about one AWS account, one app, one runtime, one region. We're talking about all of that many times over, thousands of times over, with all of the teams involved and all of the processes, and making this all come together, and everything you see on here, making that possible.
All right. So let's start with the bottom, which is read. And you're thinking, Rosemary, I did not implement monitoring and observability in my system until after I created everything, which is true. Right? Like, yes, there's a little bit of a logic.
Did you even do it then?
Yeah, and did you even do it? Is it even still logged? I don't know, right? But the reality is actually our systems, right, exist already, right? And we need to be reading information about our systems in order to continue changing them. Kind of a chicken or egg problem. Monitoring and observability might not be the first thing you think of, but it's a foundation to make informed changes. If you can't read information about what's in the existing state of your infrastructure or security, you have no idea what changes you're going to be making and if you can do them safely.
And you know what's interesting is the framework, when Rosemary was like, oh, hey, this is the big idea. The exact thing she just said, I was like, wait, read? Why? Really? Is that really first? Don't we need to make something before we can start reading from it?
Yeah, well, read is like the simplest API to implement. But it's also, the reality is, again, brownfield infrastructure exists, right? You've been building on AWS for a while, or you have infrastructure that exists, and now you need to get information about that system in order to change it, right? Because what we're supporting from a scale perspective is also evolution. So we need information. And Terraform providers also need to read information first before making changes. So if we take that on the atomic level and scale it up to a global level, well, the same rule applies, right? So what do we mean by read? What are some things that you should be considering? Well, we'll break it down into infrastructure pillar and security pillar. From the infrastructure perspective, we're going to be thinking about monitoring. We're auditing changes to infrastructure. This is beyond your change management system, beyond implementing some kind of change review board, right? This is actually being very deliberate and very organized about a system to audit those changes. You're going to identify drift. Drift can exist between environments, but can also drift between actual state and desired state. So what is as code? What is in AWS, right? And also, you want to be thinking about validating policy conformance in your infrastructure. That means, am I introducing some misconfigurations? Am I using the correct database version? Am I using the correct machine image? Monitoring is thinking about looking at the known unknowns, right? It's knowing that maybe there are some things that you don't know about the system, and point in time you need to get that information, and you know what you're looking for to a certain degree. But security requires observability. That means point in time understanding what is happening in that system, what transactions are occurring. That means auditing system access. Who's accessing what services are accessing other services. We need to think about identifying vulnerabilities, right? Are there third-party dependencies that we're using, and we need to be remediating those vulnerabilities as well. And we want to validate artifact provenance. Supply chain security is a big concern right now. We're thinking about how do we track and trace all of these artifacts that we've created and any third party that we're using, right? So we have to observe that point in time, right? It's no longer enough to say, we'll statically read this information. We have to be constantly doing it over and over and over again.
What's interesting is we have this top-down perspective, this global system, which he's talking about in context of read, but this also works bottom-up the same way if you're a developer. I mean, think about just doing a Terraform plan and apply. What happens first? Well, we read stuff out. What happens in Vault when you need to create a certificate? Well, first up, we have to do a read in context of, well, validating if you can actually do any of the stuff. And if we really want to go low level, first time you got to create anything, you're probably going to read docs, too. Does that count?
That counts.
Does that count?
Yeah, docs count, right? The docs might not be right, and maybe reads a little bit different these days. But yeah, hey. So we're going to actually talk about this from a technical perspective. We went conceptual. We're going to dive into the technical perspective, right? We're going to look a little bit about how auditing, validating, and identifying all of these systems work within a technical context. And we're going to show 3 products right now, but we'll be showing more, so don't worry. We're going to be talking about how you can use Terraform to audit infrastructure changes and identify drift. That's one of the things that you can do critically across a large number of your environments, services, and more. We're also going to be looking at how we audit system access, right? What are the ways in which we read and observe how someone is using the system and what they're accessing? We're going to do that using HTTP Vault, which is a secrets management system, and HTTP Boundary, which is for secure remote access management. So if you want to SSH into a machine, right, we can control who is able to access that machine and do it with sort of an ephemeral timeline for them to do it. And we will not be showing this right now, but as by extension, it also means monitoring your systems. You can do that with HTTP Console, which we'll show a little bit later.
All right, let's do some code here. Oh, let's see. Can I successfully switch over to my amazing screensaver of traffic? Well, let's start with some setup here. And of course, Rosemary, interject at any given time. So what we have here, this is going to be our demo code base. We'll have the link to it up at the very end of the presentation, so you'll be able to get to it. What this represents, this is, first up, it's a monorepo, not because we're trying to push a certain ideology around that, but just simply it's good for learning purposes. But what we have here is we have 5 different AWS accounts mapping to these 5 different folders of code. So just to show proof that these actually exist, if I hop over here, you can see one such of these accounts. This one specifically is going to be the global one. So in our architecture, it's pretty straightforward here. We have one account that's serving as the hub of this sort of hub and spoke architecture, and then 4 other accounts that are serving as sort of those actual sandboxes where we're developing applications. 3 of which are running Kubernetes, 1 of which is running Nomad. Now, the actual app itself, it's just a fake service, nothing to really write home here. Rosemary loves this UI. She's always like, she loves the blue lines. This just really did it for us here, right? That's the beauty of the app. So how is this all connected? How do we make changes and get up, right? Well, first up, we're using HCP Terraform, so you can see the various workspaces here, each which contain the credentials for their given AWS account. And within each, they all have a workspace, this workspace being an order of operations or separation of concerns of what we might need to do, such that if we change stuff within the global sandbox, within the global AWS account that's serving as that hub, it will only make the changes in the associated workspace. So already from a read perspective, this global idea that Rosemary has been talking about, right, we get one centralized view into all of those things that are happening. And we can dive a little bit deeper here. If we head into the infrastructure aspect, we can see all sorts of information of what's happening across our entire code base. So everything from just basic metrics to the resources to even the different work that Rosemary and I have been putting into this particular workspace itself. And even more details if we jump in here and we can see what's been going on, as well as what Rosemary mentioned, a Sentinel policy. So policy is code that's shift left. Rosemary, give us your thoughts on that.
Yeah, so the idea is that if you do want to check for a configuration, possible policy conformance, you want to be looking at that early in the process on the configuration side. So what we're doing is we have a policy that checks whether or not certain configuration has been set. If not, do not pass, right, or fail the test, it's the kind of thing. It's effectively a test to make sure that the right configurations are going to production when you need them.
Yeah, and this one is no Friday deploy, right? And we follow that absolutely. We don't follow it. It's OK. So back into overview. That's catching stuff before it happens, but obviously stuff is going to happen after the fact. And Rosemary mentioned drift. Sure enough, we have drift here. Something has changed outside of our code itself. Specifically, someone went into this security group rule and put an egregious description and caused drift, and Rosemary is going to give us her thoughts on some drift stuff.
I'm surprised no one just opened up the security group rule. But the thing is that you will have drift that you want to bring back into your code. There's also drift that maybe is sort of a way to detect whether or not something has changed upstream that you may not want to bring back into your code at all. You want to enforce a policy, right? And the question I typically get is, OK, why should I be doing drift detection when maybe I can check a policy that says, oh, enforce this all the time, run it every day, and make sure that the configuration overrides something that's happening in the live environment? Well, there are break glass changes that you're going to be making. Those are emergency fixes. Those things you might not be able to avoid, and you do want to bring those changes back into infrastructure as code. Furthermore, AWS has some really powerful capabilities in terms of auto scaling and things like that. Those parameters may or may not get reflected immediately in your infrastructure as code. You might just have it automatically set. So you do want to make sure that those are not necessarily problematic things that, from a drift perspective, that you want to bring back into your infrastructure. If you do want to bring some of these attributes back into your infrastructure as code, you can do in Terraform Cloud something called a refresh-only plan. And what that will do is just refresh everything and bring it back into state so you don't have to worry about it further.
I like how you sort of set us up for the auto scaling, because we'll see that here again play in. But so this is that bird's eye view and detailed view into all of the infrastructure, everything that's happening across all of your different accounts. Rosemary is talking about scale. How do you get to it? You need to be able to read all this information before you can safely make that next move. But what about for secrets? Well, within secrets, we have Vault, and we have the audit devices there so that we can set up logging. So for Vault, we actually have one set up for our main Vault cluster here for secrets management, one into CloudWatch, right? So if we head over into CloudWatch, we'll see that we've got a log group set up that's going to show us every single transaction that's happening within Vault across all of our secrets, regardless of what sandbox is going on. Let's just pick one at random here and throw Rosemary into the deep end and have her tell us what the heck is going on and with all of this stuff. Go.
Thanks. So if you're not familiar with Vault, it's a secrets manager. So you can store and rotate secrets, right? It will do that on your behalf. It allows you to sort of add some level of automation to managing secrets. What we've done is we've linked sort of a set of services and their identities to a secret that they're accessing, which is an app key. So here you can see that there is a game service that is accessing a secret at the path let's find that. Oh, secrets data app key, right? This means that you can set up different API paths within Vault for you to share secrets across applications, or even better, not share secrets across applications, right? You're able to control and identify what secrets are being distributed. And secrets are the gateway for access, right? For something to connect to something else. So what we're effectively doing is trying to read information about the system, again, tying back to security observability. Point in time, we understand this is what's happening in the system and who's requesting access to something else further.
All right, so speaking of read, sometimes we're going to need to really go in and read what's happening directly on site, so maybe specifically within one of our nodes, within one of the actual EC2 instances. So if you're on something like EKS, really if you're using anything like an auto-scaling group or launch template or any type of resource where you may have nodes coming in and out that you might need to actually access from a secure remote standpoint, how are we going to do that? Are we just going to keep a static list? I guess you can do that. That's certainly an option. But when we're passing around SSH keys, wouldn't it be better to have one interface, right, by which everyone goes through and then accesses those things, and such that we can actually control all of that that's going on, but also make it so that any nodes that are available, well, they're available, they're taken away, and it responds to changes that are in scaling? Well, that's exactly what we have set up here in Boundary. So within Boundary here, we have these different host catalogs that are dynamic, such that our game catalog here is tracking all of the EKS nodes as they come up, as they come down, as they're created and destroyed, and it becomes a target by which our users can access, assuming we've given them the ability to do that. So you set the flag for auto-scaling, and why don't you talk about some about this?
Yeah, and I think what it really demonstrates is the fact that you have powerful read capabilities just by extending the cloud infrastructure that you have, right? You're reading a catalog of EC2 instances, or you're reading catalog of endpoints that you've registered in AWS, and you're able to extend on that, right? It doesn't have to just be in HTTP Boundary. It could be in any other tool or automation that you have. Foundationally, read is the way for you to understand that system, and if you do want to make further changes, you can always do an informed change based on that information. What's also really important is, again, brownfield infrastructure. You have it already in place, right? It's very hard for you to try to import or make new changes to that infrastructure without actually reading information about it in the first place. So that's one thing to consider as well.
Okay, I think let's see if I can switch this back to slides correctly.
Yeah. So we talked about read. Now let's go to create, because we were like, we have to create things, right? Well, you will create new things, right? We create new things all the time, especially in our AWS accounts. And this is what happens when you grant someone a new AWS account. They're going to create new things in it. And so creation, though, in order for you to scale, requires two foundational elements. First, modularization, and second is considerations around access control. Modularization is important for infrastructure because it allows you to isolate changes to parts of the system, right? Anytime you make a change, there's a blast radius, and you have to make an assessment of what that blast radius will be when you make a change to any large group of infrastructure. So the more you can isolate those changes, the more you minimize the blast radius of that change. Which means, by extension, you have to decouple infrastructure dependencies. This is really tricky. It's hard to say that you're going to deploy servers on a network and do it independently of each other, right? There's going to be dependencies in your infrastructure, but you do have to understand what they are, and you do have to map them out, and hopefully decouple them in a way you can make changes to your servers without affecting your network. And from a security perspective, we're thinking about isolation for least privileged access, right? We've been hearing a lot about trying to secure our cloud environment as best as possible, which means making sure that you have the right access control policy, and hopefully that means minimizing the amount of access that someone or a service needs. But more importantly, and I think we don't really talk about this clearly, when you move to larger scale, it's incredibly important for you to decouple your identity from access policy. I mean, if Cole decides that he's going to switch from the game dev team to the social team, he doesn't need access to the game database anymore, right? He doesn't need access to that data.
It'd be nice.
Yeah, well, you don't want to. If you couple the identity to the access policy, it makes it a little bit challenging to pivot and make dynamic changes to your system and ensure that someone has the right level of access at any given point in time. So if you can decouple the identity from the access policy, make sure the policy is set on its own. You put the identity of either the user or the service separate from that, and you can tie them together or attach them as you need to. That means you can effectively make changes to policy independent of identity, and you can always relink identity to new policy, right?
Yeah, and bottom up, right, modularization, you're abstracting so that you can build faster. Right? You put together nice little packages that you can string together. And by the way, also creation, although we tend to think infrastructure, all the connections, all the security pieces, right, those are still the cables and the keys, metaphorically, to get this all done.
Okay, so let's talk about create. The first thing we're going to talk about is creating infrastructure, and we're going to show how we can decouple infrastructure through modules, and that way we can individually, Cole and myself, iterate on infrastructure at scale without necessarily stepping on each other and making conflicts, right? So we'll show that using Terraform. We're also going to show HCP Vault, right? We're going to show how we're decoupling machine identities and human user identities away from the specific policy of how someone is going to access the secret. And we're also going to be showing console as well. Console is a service mesh, and what we're going to be showing is how you can decouple the machine identity away from a service identity, right? So even another layer of abstraction on top of that, and then you can control policy between services, right? So as we layer these abstractions, yeah, there are some challenges to it, but by decoupling all of these components, we can individually evolve them as we need to. Oops, sorry.
All right, so let's hop back over into the demo here. We're going to go right back over into our code. We're going to take a look at some of the modules. If you need to go and make a new sandbox or maybe we're in the game and we decide that we need a new development infrastructure cluster or something like so. Well, that can seem like somewhat of a daunting task, but you can see within the runtime, because we've taken time to create modules, we can get that done in about 8 lines of code. We decide on what should be in here. That makes building and iterating a lot quicker. And if someone decides they want a new runtime, like Rosemary, who's like, Cole, I want Nomad.
Yeah, that's
And
actually what I told you.
and I want to do the Nomad. I was like, okay, perfect. All right, you're going to come in here. You're going to make the module. And she did. She made a nice module for both Nomad servers and clients. And we can go down to her report sandbox that she was responsible for. Go to runtime, and we'll see the exact same pattern. Within this very minimal amount of code, we have Nomad servers and clients set up, right? And now anyone who wants a new runtime can make it. Now, these are local modules. Granted, this is for this monorepo. These are ones that are just confined to just this code base. However, there's going to be 2 other cases here. One where you might want to consume the knowledge of the public, right? You wonderful people, our other community practitioners. That's where we have our Terraform registry, where you've got 18,000 that you can choose from. But if you would still like, if you'd like to do the in-between, where you're going to have reusable packages of code that you want anyone else to use that's just confined to your organization, well, that's where we have the registry. And if I hop over here to our private registry, we see that we've got a couple of modules that we've created just for internal use only. So let's pick one. Let's pick the Nomad one Rosemary had. You can see on the screen some other information. And Rosemary, I want your thoughts on modules.
Yeah. And so really what this comes down to is treating your infrastructure configuration as if it was actual code, right? Just as software developers use third-party libraries, right, or they use internal libraries that have been standardized for them from a security perspective, you should be offering the same for infrastructure. Now, the question is, what's the difference between creating a local module that maybe you are the only one who's going to be using, or your team is the only people who are going to be using, versus someone else, right? If you do have to distribute on a wider scale, you eventually do have to move it to some kind of artifact repository with some kind of artifact management on it, right? After all, you do want to make sure that you validate the artifact provenance, shout back to Reed, right? Validate the artifact provenance, make sure that you're not introducing misconfigurations or possibly any misalignment into your system.
All right, so next up for this area of create, we talked about the decoupling. So let's go over to Vault. And within Vault, we're going to take a look at the auth methods here. We'll see that for each of our Kubernetes clusters here, our Kubernetes environments, for the game, social, and store, they each have their own way to authenticate into Vault to pull different secrets. Now, in this case, for this demo, a lot of them are pulling from a global application key. And despite the fact that they're consuming the same secret, they all have different ways that they go about doing them. Now, the Nomad runtime also doesn't use any of those methods and actually just uses the token one. And if we hop back over, we've also created policies. So if we come over, we have a policy for that global application key, very simple, just a read policy that the rest of the roles that those auth methods are using get access to. And then finally, we have another policy that Rosemary's database is using, and she can talk about that.
Yeah, so it's important to recognize we're decoupling the definition of policy away from the authentication of the identity, right? Vault has a couple different kinds of authentication methods, right? You can do it through AWS metadata. You could do it through JWT, OIDC, right? There are a lot of different mechanisms for you to validate an identity to allow someone to authenticate to Vault. And you have the flexibility to choose what kind of identities you're going to apply. But the policies themselves are defined independently. So you can always link a policy to a different set of identities. So if you have a development team that you know always is going to access the game database, you can give them this access, or the report database in this case. You can always attach this policy to that identity, right? But you can always shift those policies as you need to.
All right. Again, for all the apps and all of the developers, all the platforms, you still get that one view, that one place to do all of it. And the final thing over here is within console, seeing all the services across all these sandboxes in one place with just thinking in context of identity. Of course, if you want more details, you can dig down into any one of these. Go into instances here, and of course we could see the raw information about, say, the what's going on in context of Kubernetes.
Yeah. So in terms of creation, anytime you create, anytime you create console or a console service and register with it, right? We're able to create a machine identity and a service identity as an abstraction. What this means, and what you don't really see fully, is that all of these are actually connected by different Kubernetes clusters in different AWS accounts, different networks, different everything, right? But it looks as one view, right? So you're able to read information and control the policy, right? Because we have a layer of abstraction on top of it. So what's really powerful about this is that sometimes you do have to create abstractions in order for you to scale and create even more parts of your system.
Yeah, so nice in one place, and let's take that up to another level while looking at something like intentions, where we even have one place to set up connectivity between the different services if we want. So if we want to create some sort of new connectivity, we're able to come in here, select a service, select the destination, and of course choose some other options.
Yeah. Okay. All right.
Back to the slides, shall we go?
All
right.
Yeah, we're going fast. You're going fast today. All right, so finally we have made it to update. We are about half the way. So we are talking about update, and update primarily involves standardization remediation, because from a lifecycle standpoint, this is what we call the painful refactor, where we cry because we have to refactor something, right? Because we standardize. Standardization is very important from an update perspective, because the more you can create a consistent application and infrastructure deployment, the more you can actually gain predictability from changes and rollbacks, right? What happens is if you don't have standard infrastructure, you created everything individually and in a unique way, it's very hard to roll out automation and make sure you update everything in one broad sweep, right? So it's important to improve the overall predictability of changes and rollbacks, right? And from a security perspective, this really actually means remediation, right? Remediation is the practice of updating our resources when we do find anomalous behavior, right? Whether it be vulnerabilities or something else that is causing a cause for concern. And we want to improve the speed of remediation, right? That's the hope. And so if we can update in place, what we're really looking at is the difference between minutes and hours. Now, there are some debates on whether or not you should create something, delete something, et cetera. We're going to get to delete. But most of the time, you may find yourself doing an in-place update still, just because it means the difference between implementing a change over the course of minutes versus waiting hours or days.
And of course, that's, again, important to clarify. There is the global system that's making the update, and there's what you're doing from the bottom up. That may either be an update in place, as Rosemary has talked about, or some mix of create and delete to make that happen.
Yep. Okay. So what are we going to do now? So we have a couple of things that we've done. We're going to show an update in the form of standardized deployment, right, in operation. So we've already standardized some of our deployment and our operational capability, and now we're just going to make one-click update, which you're like, what? One-click update? And we will show that. But we're also going to show rotating a secret live. Yeah, so everybody, hope it goes well. We're going to rotate a secret live once across 8 applications and not do anything, right? We're not going to manually go clicking and looking for the application, right? And so that's an update of a secret. We'll do that with HTTP Vault. And then we're going to be showing how we can make a break glass update. And the break glass update is audited and recorded through HTTP Boundary. So the first we're going to show is HTTP Waypoint, which is an internal developer platform that wraps around Terraform. So for developers who don't really care about Terraform, right, you can look at HTTP Waypoint.
All right, back we go. So we already sort of set up the concept of a module. So if we hop over here, we have this HashiStack Nomad module. We also have one for the Kubernetes deployments as well. Now these modules, there's of course something that we as the platform engineer, the platform team could use. Oh, let me filter that out here. But they're also something that we're going to make available for our developers to kick off using Waypoint. So this is going to be the internal developer platform that Rosemary talked about. Now if we hop over here to Waypoint, it's going to take a second because Wi-Fi is working so wonderfully. Here we go. Over to applications, we'll see that we already have 5 applications going that our developers have come in and made. Now, interestingly, we'll see that this is at version 3. But if we go into, say, one of these apps that was deployed previously, like the live feed, we will see, once it opens up here, that it is actually ready for an update. Now we can view the information in here, but if we go over to the platform engineer's perspective, seeing what's going on over here, we can get some more information. And sure enough, once we get it loaded up, oh, we're getting there. We can do it. Into overview, we can do it. All right, we can see that, hey, here's some information. You're using version .2. Version .3 is available. If you would like to update, well, we're just going to give you a very easy way to do this. Now, this allows us to go in and make changes to this module, have those propagate outwards, but still give each individual team or people working on this the ability to update when they're able to. What are your thoughts, Rosemary?
Yeah, so it's important to recognize that you do have to make in-place updates. We're not deleting the app and we're not recreating it. We're not telling application teams you have to do this, like the sequence of events. Really what it's doing is saying, okay, we have an update available, you press the update, and in minutes you give the update, you push out the update, right? So this is how we're actually codifying how we're pushing out libraries and other artifacts.
All right, so let's see a really fun update. If we go to our service here, we'll see that these are all drawing a common global application key of word bar, because what is a bar without foo, right?
Don't print your application key with your application.
Well, I mean,
that's just a disclaimer, right?
It
We're doing it here for the sake of the
comedic merits, but anyhow. So we need to rotate this. All of these are using this. Okay, if you're going to do this manually or piecemeal or whatever, then you're not going to have a fun time. But we've got it set up such, since it's through Vault, across all these different sandboxes, that we can just go into Vault. Let's go into that secret itself, the app key. We're going to patch it. We're going to do one of those updates, right? And I'm going to just change this to the word, you know what, actually, let's make it reinvent. Yeah, and then we'll save. We'll save that. And now with that done, this rotation is going to spell out automatically. In fact, we're going to kind of watch this happen within console, and Rosemary's going to tell us some more about rotation here.
So this is actually happening because we have some automation behind it, right? Something called Vault Agent is detecting the change in the secret and then reloading the application on our behalf. If we were to do this manually, we make the update in a secrets manager, and then we have to find exactly which applications we're referencing the secret. But because we have the automation in place, we're able to do an in-place update of a secret rotation, or of a secret while minimizing the overall downtime an application will experience, right? So all of these changes will get rolled out to the 8 applications that we have, and Cole and I don't have to go searching for which applications depend on it. We can also go back to audit logs and read which applications are getting new secrets as well.
And don't worry, we will still be just as paranoid when we rotate it, but we will use the power of refresh to see that the changes that we wanted have happened. And if we click on one of the apps here where we're displaying our application key to all of the audience here, we'll see, hey, well, here it has been changed to reinvent across all the applications, just that simple operation. All right, so let's take a look at the time where you need to hop in and actually do something in, say, one of the nodes. So what I'm going to do, we've already seen the host catalog, so we already know that we have access to these different underlying nodes. But as a user, we're already logged in, and we have ones that we're able to connect to and do things to, and we just happen to have access to all of them, because it works out that way. So let's connect to one of the ones in Nomad and pretend like we're going to do an in-place update. So I'm going to click connect into here, and we're going to load all items as we do.
Yeah, so if you're not familiar with Boundary or you haven't checked it out yet, it is secure remote access management. So if you have multiple any TCP endpoints that you need to control access to, you can link an identity and a policy to access for that to that endpoint.
Yeah, and you'll see we're already into the shell here. All we had to do, I didn't have to do any finagling around in iTerm or anything like that. And once this hops in here, we'll see we're right in the node itself, and we can pretend that we're doing something like making an update here. So we'll just say reinvent again, giving me my double quote. All right, there we go. Got a little latency here. Oh no. Oh no.
And while this is happening, you'll notice we didn't pass any SSH keys. So part of this is being able to inject credentials as someone is going to be accessing it, right? So whichever user is going to access the system, they don't have any awareness of the credential. We're injecting that credential for them. And we, again, decouple identity from the access policy of this credential. We limit it to exactly what access that user might require.
And even though I don't think Rosemary will ever see my double quote typo and give me stuff about later, little do I know that in the background, she can see everything that's going on. If we hop over to sessions, we might be able to see, oh, someone's in my Nomad node messing around, but Cole didn't do that. He was supposed to stay on Kubernetes, so I'm going to cancel that session. If I hop back over, we'll see that I've been kicked out. I'll end the session here and think that I've gotten away with it. I never get away with it, though. It's fine. Once this ends, we can go back over, and later on, Rosemary can go into one of these session recordings and see every single thing that I did, including my random typo, though, and this nice play-by-play.
Yeah. And this is not just from useful from a security perspective. I actually use this to reconcile automation. So any manual changes I make to a resource because I didn't fully test it or I have to do a sort of a break fix, I'll actually copy the commands that I've entered here and then put it back into automation. So that way I can, the next time I run my automation, it has the update in place, right? So I'm able to do a manual update, but then bring that back into automation and reconcile the drift.
And look at this, check this out. You can select it. I feel like I ran into that by accident when I saw it happen. I was like, oh, that's so nice.
Yeah.
All right, so I think we can hop back over to the slides now.
Yep. Back and forth. OK. So finally, we've reached delete, right? And delete really is about immutability and ephemerality. This is probably the most challenging set of principles for anybody to grasp because it really fundamentally changes every workflow that you have in your organization. Immutability is changing resource by creation and deletion. Rather than updating in place, you're creating a new resource entirely and deleting the old one with all of the changes, right? And this is helpful because it does support lower risk refactoring patterns, right? This is common in blue-green deployments. This is more common now, especially if you're familiar with immutable image pipelines, which we'll show today. But immutability has become a core principle in how you manage cloud infrastructure. But it's really challenging to think about from at least a mental perspective across an organization. Telling someone that you're going to delete an old resource and run the risk of potentially causing some kind of downtime to the system is often very hard to convince someone to do that kind of pattern, right? But it is actually very useful, especially if you want to do something lower risk, but you also want to make significant changes. The other thing is that from a security perspective, there's ephemerality now. Immutability sort of leads to ephemerality by extension. Ephemerality changes the time to live of resources, so you reduce the overall attack surface, right, and improve the overall security of your system. Ephemerality means that you have to bank on resources not being long-lived. And that means you do have to support resiliency patterns for short-lived resources. One of the most challenging things that I tend to run into is developers who are like, well, my secret changes every 2 days now. My application doesn't know how to reload to handle those changes, right? So those are some resiliency patterns that have to get built on any dependencies when you move to sort of an ephemeral resource.
And the bottom-up perspective is where I think that was the first point where you and I, we had to just keep working on it. Because I don't see it. Because from a bottom-up, we've already seen delete in action before, right? We've seen it from those actual actions where in create, we said, and an update was like, well, sometimes you're going to delete and then do a create to make the update happen. So I guess the question that I want you to answer the audience is, well, what about from the global perspective? Where does an actual delete happen from the whole system? What does that look like?
Well, deprecating a platform is actually a global delete, right? Because as we iterate over new systems, especially because we have new offerings that we're trying to introduce to developers, we will have to deprecate older parts of the platform, right? And a global deprecation is challenging, but it is a global delete. You use immutability to handle the migration of maybe a certain subset of services that are running on infrastructure that you no longer want to maintain, and you want to move them to new infrastructure, new ways of running, right? That deprecation is a global delete.
All right.
So.
Oh yeah, right.
No,
yeah, I almost switched it too fast.
All right, so let's talk about delete. We're going to show immutable image pipelines. If you're not familiar with immutable images, it's the idea that you can build a machine image and deploy the machine out with that new machine image with all of the updates in place for that image, right? And you have to delete the older versions, right? And so that's going to be using a combination of HTTP Packer, which is a metadata registry for machine images. And then we're going to be talking about creating and deleting credentials using HTTP Vault. These are not updated, rotated credentials. They're very different. These are dynamic credentials that have a limited time to live, meaning they are leased, and then once they are gone, they are gone. There's no getting them back. There's no recreating them either, right? So these are dynamic credentials. And then we're going to talk a little bit about what the global delete looks like. A global delete will look like sort of what we call an ephemeral workspace or ephemeral state. So these are more common for dev environments or environments that you feel like should only have a certain time to live.
Mm-hmm. All right, so let's hop back over to now. Now it is time. So, can we see it? Oh, good, we can see it. So let's start with the Packer side of things. So the Nomad clients and servers are, let me actually go find the correct interface here. Those are all using, obviously, machine images under the hood, specifically AMIs. They're going to have different versions of them. We're tracking all of those within Packer itself. So let me get back up to the main dashboard here and into Packer. And we'll be able to see some of that. Yep, this is test of Wi-Fi's ability to be incredible. We made it. All right. So we'll go into the client itself, and we'll see some information up top. If we go to versions, we'll see there's been 5 different versions, 3 of which have been revoked, 2 of which are active, 1 of which is the latest itself. This is kind of also that neat idea of, well, there is somewhat of a global deprecation here because 1, 2, and 3, though we can go back to them, they are taken out of the picture. Now, seeing where these are actually used, let's go into one of Rosemary's workspaces and expose her work, shall we? Let's go to the reports here. Once we get into, yes, we can do it. We can filter.
And while we pull up the workspace, the workspace that's using these images, it's important to recognize that if you make these updates and you do push, right, you will have a life cycle of revocation for various images. But more importantly, the challenge is often who is using the image, right? It's the same question we ran into before. Who's using the secret, right? And making sure you actually update your live infrastructure with those images. Because you can build an image that has no vulnerabilities, but if it's never rolled out to your infrastructure, well, it's still not more secure, right? You're not more secure than before either. So that's why there's a sort of a secondary component to this, which is how do you identify, right, when you need to roll out these new images?
So let's say that we did the switch over to that version 5. We can actually see this happening in Drift. So Drift, again, is being useful. So that read is being useful, and again, for managing the system. And once this loads in, we'll be able to see the switch to that new image. If we open up our launch template, we'll see that we have a pending switch to the new AMI, which while that's loading, let's go ahead and take a look at version 5 here to see some of the information for the different regions of them.
So yeah, they're all being pushed to different regions, by the way, and we actually have one view of that metadata now.
Yeah, so there we go. We can see that it's pending this new change. And Rosemary, what are your thoughts on that?
Yeah, so the point is that as you create immutable images, there's this process as well of rolling out that immutable image across your system. So it's critical that you have both components. And if you do approach this sort of delete, you have to have some kind of revocation lifecycle around it as well.
OK, so that too, and also, it just kind of calls back to when we're talking about deprecation. We also saw that with modules too. We're using the version .3 of that HashiStack Kubernetes app, whereas version .1 isn't being used anywhere, but of course we could go back to it if we want. So let's take a look at an actual big delete. You're going to have perhaps the need for something like a development environment. Anyway, the infrastructure, or it might be temporary. So let's go over to a case. That's it. And we're all great about tearing down development resources, right, Rosemary?
No. No. I'm going to be honest. I'm pretty sure we've left some of these resources up for a year now.
That's true. That's why I keep filtering the projects. You all don't see that 2023 is actually still up there, but we go in. We can see there's a development infrastructure here. Not only, but this time we learned our lesson because we got asked, why is this other stuff up? And we've gone ahead and set this up with what's known as an auto destroy. So once I get into it here, let me in.
You can just hover.
What just happened? It left me. Oh, yeah, I meant to do that. OK. So once we're into here, we'll see that, hey, in 9 days, this is going to go away. We'll see that that we've got this set up, and we can set up, of course, ephemeral workspaces with this auto-destroy. And what's neat about this is this will run a destroy run, so it'll get rid of all of the resources for us, but it won't get rid of this workspace, meaning that we can see everything that's happened in the past, and we can choose to bring it back up if we so choose. Thoughts on that?
Yeah, I think at the end of the day, right, we are moving more toward ephemerality, right? We're using it not just as a way to optimize our resources, but it's also a way for us to add a compensating control from a security perspective.
All right, so one more thing here. Let's talk about dynamic credentials. Granted, these are being fueled by Vault. We're going to actually see this happen through Boundary. What we're going to do is access an RDS database. So if we head over, we'll see as our Boundary user, we do have the ability to access our database. We're going to do a connect, and we're going to see those credentials load in. We're actually going to get those temporary credentials right here at the beginning. And so keep track of this username here. So it's just 6811. And we're going to actually connect in as this temporary user. So let me hop over to my shell here. And once this sets itself up, Let's see if I have it in history. All right, perfect, perfect. So I'm going to fill in these credentials, and Rosemary, talk to the audience so they don't get bored watching me do this while I fill it.
So what happened is that we set up dynamic credentials, which means anytime that Boundary needs someone to access this database, we get a new username and a new password for this database, which is kind of strange, right? Like that's a lot of usernames, a lot of passwords. But they have a limited lifecycle. So in this case, we have 1 hour lifetime for this username and password, which means a developer who does need to access the database only has 1 hour to do anything they need to do on this database. Even more importantly, we've tied a policy to these credentials. They only have read-only access. They cannot add things to the database. They can't delete anything. They can't drop tables, right? So we are almost mimicking what the application itself would be doing, and we're limiting the access the developer would have to the database. And once they're done, then we can end the session, and that set of credentials is revoked, right?
And let's see those new credentials come into play. We see we have 6811 there. We'll end this session, and then we'll connect back in as the same user. Of course, we'll get an entirely different user here once this is it. I don't think we set up session recording for that, but it's still something.
Yeah, it's only for SSH. So.
Right.
Yeah, but in terms of database auditing, right? If you do want to audit the actions on your database, right, you also have to have the policy in place. So when this loads, Cole will just get a new set of credentials. We won't re-log into the database, but
I promise I won't make you watch me backspace through through the stuff.
Yeah, but the tricky thing. There we are.
Yeah, there's a difference.
So it was 6811. Now it's 6918.
Okay, so let's hop back over to the slides.
Yeah. So the important thing to recognize about dynamic credentials is that, well, they are dynamic. That changes how your applications behave. That changes how how anybody accesses the database or any other endpoint that you have. All right. So finally, we are at the end, which is as code, self-service, and systems of record. I did not create individual sections for any of this because.
Why?
Well, I think it all kind of goes together, right? You need to have the bottom 4 in order to have the top of the roof, right? It's very hard to do as code, self-services, and systems of record without sort of the pillars at the bottom. And that's because, well, as code is really building configuration or policy for automation. A lot of folks say, okay, I'm using Terraform, I'm doing infrastructure as code. But in order for you to scale it effectively, you need to have some foundational practices and principles in place, right? And that's because you want to enable orchestration across systems, right? Terraform is for automation. You want to also enable orchestration across larger parts of your system. Self-service is actually something that sort of takes another step up because eventually you'll have to abstract the complexity of knowledge for developers and other folks in your organization because eventually someone will want to extend the system to support their business needs. And this is really important, especially as we have new service offerings coming out, right? We're evaluating these service offerings within our organization and how we can support those capabilities most effectively with our development teams. And finally, the top of the roof is the systems of record, right? This is sort of what we hope to achieve, which is a global inventory of infrastructure, secrets, identities, and policies all in place, right? With this big global system of record, we have this visibility and orchestration across our systems, and then we can scale even further, going back to our read capability and continue to feed that loop and that cycle of read, create, update, and delete.
Yeah, so you may be saying like, oh, well, I've got stuff as code. I even have a little mini developer platform. Am I ready for scale? Well, it's interesting, as a developer, our first inclination is, well, what's the biggest and best tool out there? Let me start with that. And you start with these things, you try to go towards scale, and you wonder, oh, well, I can't go any further. Because if you skip those foundational blocks, these final ones, since they're at the top, they're not going to work as well.
Okay. So we're going to do the final big one. This is a big one. This is self-service, infrastructure as code, and a system of record all at once. So we're going to show self-service through Waypoint and Terraform. We're going to show a system of record through console in that giant service catalog. And we're also going to show a system of record of how we use that secret from Vault. And then we will be deleting that application. From the platform operator's perspective, we're not going to show Boundary and Packer again because that's partly platform operation perspective. But if you are trying to enable scale for other groups in your organization, we're going to show that workflow.
Now, despite this being the biggest, because we've put in the work, ironically, the demo part of this is going to be the shortest. So that'll be nice. Hop back over. So our developer has now heard of all the work we've done, and they say they want a new application. But this time, instead of bugging Rosemary and myself, we're like, go to Waypoint, go make an app. Don't worry, we've set it up. How have we set it up? Well, if you recall the different modules we created, these are what are being used under the hood. And let's say they want to make a new application within the Kubernetes cluster. Well, they're just going to select that. We're giving them the ability to add some customization. We'll just call this reinvent. Obviously, you could add a lot more options here. And click Create Application. I can find this for 2, obviously, because it's a demo, but you could give them a lot of other options. You could even make drop-downs and confine them to just specific options. We'll see this kicked off. Now, if you're the platform team and you're trying to keep an idea of what's going on, this is obviously happening in the background in HTTP Terraform, so we can still see that this application is going through all of the same things that anything else that we create have had to go through. And we'll get just as much information. Once this loads up here, we will see, oh, it's coming. I feel like it's going to get there.
Yeah, they'll show the services.
Yeah. Oh, yeah, we can show the services while it's going, right? So we're going to watch this pop up in here. But, yeah, there we go. All right, so we see this has been made. So we have a new workspace. Of course, we're going to be able to keep track of it. Did it a few seconds ago. Oh, and we can even see the service coming online. So actually, I think this is already finished. We're just taking a while here to actually see what's going on. And here we go. Yeah, it actually finished beforehand. All the new resources created. It's gone through our policies. The applies happen. And of course, if we went back to overview, we get all of the information. And of course, we already saw the reinvent service pop up here. And of course, we could go ahead and start connecting it to things if we wanted to. So we'd be able to select the reinvent service and do any of the other things. What are your thoughts, Rosemary?
And I think it's important to recognize that all of these pieces have to come together. A lot of automation in place that allows us to do global orchestration across multiple Kubernetes clusters, different runtimes, and different accounts.
Yep. And so when the developer says, I need to get rid of it, well, guess what? They can do that themselves. If I come back over to the application, do a simple delete here, and now the application goes away. From their perspective, we, of course, get to see everything that's going on in terms that there is now a destroy run queued up, and we'd be able to monitor that as well.
Yeah. So,
back to slides?
Back to slides.
Yes.
We're going to wrap up. Okay, so that was a lot going on. But if there's one thing that you're going to take away, I would say it's this slide, right? The building blocks. You're going to look at your organization, you're going to look at your system, and you're going to recognize that you don't have every single building block, right? You're going to assess, okay, do I have some read capabilities, and how much do I have, right? I'm going to look at create capabilities. Do I have modularization? Do I have least privilege access control? Update, delete. You'll go up, right? And eventually you'll find that maybe some parts of your system you've gotten to as code, some parts of your system you've gotten all of them in place. You have the system of record and you feel really comfortable with it. But as you scale, the idea is that you will hopefully have this across your entire system. Anything else you want to add?
Yeah, why is this important? Well, for the same reason that CRUD was important when you went to work on an API or develop your own. You have this framework, it paves a path so that you can get the scale. You're not home baking your own patterns and then being confused as to, well, now I can't go any further. Yep. So if you want to learn more, we have the demo repo up here. It is under my name, but we both worked on it just as much. HashiStack on AWS. If you want to sign up for the HashiCorp Cloud Platform, we have the hashi.co/cloud. And if you want more in-depth tutorials and information, check out our developer platform at developer.hashicorp.com.
Thank you, and we'll be out in the lobby for questions.